Okay, good afternoon, everyone, and welcome to the Price HVAC Controls for Overhead Systems. This is a 45-minute webinar presentation, and we're working in conjunction with Buckley Associates, one of our good reps up in the Northeast there, and to get contractors and even their salespeople a little more involved or exposed to what the price controls offering is from Price. So my name is Brad Cole. I am the sales manager for the controls division up here in Winnipeg, Manitoba, Canada. This is primarily for the overhead type controls, and we're going to do a presentation today, a little webinar to go through what our offering is and to see how you can, as a contractor, save time and money on a job site and get in and out of a job site very quickly. So the first portion will be the overview, and then I'll spend maybe about 5 minutes towards the end just showing you a brief little hands-on demonstration of how all of our controls go together in a nice, easy fashion. Okay, so I like to start my presentations with Wi-Fi. What's in it for you? Why are you sitting here today taking 45 minutes of your time, spending your time to take in this presentation or webinar? We'll go over the price zoning system overview, and then we'll get into the controller. So the PRTU rooftop controller, our VAV zone controller, Prodigy, Diffuser, talk about static pressure, and then we'll get into our web server graphical interface, which acts as a nice little mini front end for a system like this. All right, so what's in it for you? You'll learn why the price zoning system will get you on and off a job site quickly, saving time and money on the install. This is ideal for small to medium-sized spaces ranging from 50,000 square feet and up to 30-ton rooftops. So essentially, this is our 50-30 rule, and I worked with Ed Fruth. We were out in Ohio area earlier this year before all this crazy COVID stuff happened, but we were out there in February, and we kind of came up with this cool little cheat sheet or rule for this type of application. We called it the 50-30 rule, so I like that. So yeah, really small to medium-sized buildings, and we have pre-programmed controllers come from the factory. They're mounted onto the terminal unit. They're ready to go with plug-and-play connectivity. So great for a great solution for retrofits, tenant fit-ups, TIs, new installs, you know, whatever. This type of system is going to get you in this small to medium-sized market. Okay. So we'll go over the system overview. So guys, this is our bread and butter. This is really what we're going after. So typical office space, or I'm going to say a bank, like a space as big as a bank. This is where we've utilized this, you know, throughout, you know, the time that these controls have been around. And I will mention that we do make these controls up here in Winnipeg at Price Electronics. This is a division out of Price, so known as Price Industries. You know, we are one of the divisions. So these controls have been around for, you know, close to 12 to 14 years. I've been with Price for 12 years. And this is when we started to develop these from scratch. So it's not like these are just coming out of the market and we're just rolling them out. These are tried and true, and we've done a lot of installs with these. So I've been pushing these controls for 12 years as the controls specialist. Now I'm the sales manager. So yeah, these have been around for a while. So really what we're going after, guys, is an office space like this. So we run into any type of rooftop, doesn't matter if it's a constant volume or variable volume, but we're gonna look at any rooftop, whether it's a Trane, Lennox, Aon, York, Carrier, Daikin. We can tie in or put in our PRTU rooftop controller to control the rooftop with signals of heating and cooling throughout the day and turn the fan on during occupied times. In a typical constant volume system, we're going to use a bypass damper that we make at Price. So we handle the static pressure with this type of controller, and that comes right from Price. As we get into the open spaces, we might look at designing in, whether it's engineered or a design build job, we're going to look at designing in a single duct or maybe a fan powered box with reheat, and we can use the PIC controller to control those types of applications and sequences, no problem. In the office spaces that we put into these buildings, the Prodigy diffuser was commonly used. So these were used in a lot of the banks with the TD Ameritrades that we did down in the US. So what they did is they put in these Prodigy self-modulating diffusers and put in thermostats in the room. So it gave each individual occupant their own room control. So it allowed them to adjust their thermostat to move the damper based on what the demand was calling for. So if you look at all of this and you check out this, if you check out this blue cabling you see around the diagram here, what that is, everyone, guys, is the backnet cabling connected from the PRTU controller out to these different zones. So what that is, it's a backnet communication that we use to create a polling system or a polling strategy to intelligently control the building. So what it does is the PRTU will poll the zones for a demand and decide how to turn the rooftop into heating or cooling based on how many, votes or, from the zones that it gets, how many votes it gets. So it decides how many stages of heating and cooling need to be turned on throughout the day based on this demand. Lastly, if you wanted to tie all of it in together and view it on a graphical interface, you could do this with the Price web server. So this is a nice mini graphical package that we offer from Price. Pre-built graphics and templates are built in there. So it's a nice solution graphical interface that you can view locally or remotely with for the Price products. So again, great for small to medium sized buildings. This web server is not going to handle full-blown, university campuses or hospitals. It's going to look after those small to medium-sized buildings for sure in this footprint. All right, just wanted to mention some national accounts that we have throughout North America. So up here in Canada, we have a couple of big banks that have bought onto our control system and are using them and are designed in through the engineers that have used them. So BMO, or Bank of Montreal, that was designed in and spec'd in with TMP. They're out of Toronto, Ontario, Canada. And then the Royal Bank, or the RBC of Canada, through Dialogue Engineering, who's also in Toronto and also in Vancouver. So these are designed and spec'd in, and they use iterations of this layout for their banks, which is great. So every new install, say every new BMO that goes up, uses Price controls, and that's spec'd in with TMP. So it's a great contract that we have. Down in the US, we had a contract with TD Ameritrade through one of our reps in Denver. That was a nice contract we had for about 5 years with MKK Engineering. And we've done about 35 TD Ameritrades over the 5-year span, all the way from, say, Jacksonville to San Jose. So we've done a bunch of TD Ameritrades where they use this full iteration of these controls. So rooftop controller, bypass, zoning, and the web server. So we would come out and commission it, set up the graphics, make sure it all worked, and then handed it over to MKK to do their commissioning. So now what they do is the TD Ameritrade actually logs in remotely from their headquarters to view all of those sites that they set up with Price control. So that was a great contract. So keep that in mind when you're thinking about application and where it could be implemented. A bank or a typical type of building like that is a great start. All right, we're getting into the zone controllers now. So let's look at the PRTU, or the rooftop controller. Start from the top down. Essentially, this is a rooftop controller that we developed in about 2012. It's designed to control any one of the following: constant volume or variable volume type unit. It can also control heat pumps, which were commonly used in the TD Ameritrades that we went into, and then just basic furnace control. But really, we're looking at constant volume or variable volume type rooftops, anywhere from, say, 2 to 30 tons. What we're looking for, guys, is when we're designing these buildings or designing these systems, and we want to know if the PRTU can tie into it, we need to know or find out make sure that this conventional terminal strip is in the rooftop. I'm going to say 95% of the time it is. It's a remote connection where you tie in a thermostat. The PRTU is a fancy thermostat. It does some, you know, it does more, has more features than just a basic Honeywell or Trane or, you know, White Rogers thermostat that's on the wall. It has polling capabilities and a whole bunch of stuff built into it. So we really just need this conventional terminal strip that we can tie into to tie in the fan, stages of heat, and stages of cool. So the outputs and the inputs of the PRTU, the makeup of it is this. 10 binary outputs, so it can handle up to 4 stages of heat, 4 stages of cooling. You probably won't find a rooftop that has that amount, but if it did, we have the capacity to handle it. It also has 4 analog outputs, one for a VFD, one for an analog heating valve, one for a cooling valve. So this is where we can tie into a VAV type rooftop, or like an air handler that's on the roof. We did this up in Ontario, Canada with some engineered air units, and we use the analog outs to control the air handler or rooftop. 12 analog inputs, so there's a ton of inputs on this guy. Six thermistor and 6 voltage. We do give you 2 probes in the box that comes with this, known as the DAT or the RAT, so like the discharge and the return air temp probes that need to get wired into the 2 analogs that are shown in the manual. But essentially these act as safeties. They get mounted in the supply and the return duct and then wired back to the controller to act as safeties if we ever need to cut out a stage of cooling or cut out a stage of heating based on the supply and the return temps coming back to the controller as we use that as a feedback loop. Also, the thermostat and the backnet are plug and play and easy to connect and get going. All right, so just a high level, just system overview wiring of what we can do here and how this would all go together, just primarily for contractors to see how it would go. So you got a rooftop on the roof. Let's say it's a core and shell building. You got a rooftop that's there and you want to control it. You'd probably take out the existing thermostat that's hanging there and put in the PRTU. So you'd put this mounted internally in the building, not in the rooftop unit. So it's not designed to go outside in high humidity or colder type temperatures, but inside, either in the ceiling space or in a mechanical room or somewhere in the chase of where the rooftop would be. From there, you'd hook up the thermostat with the 35-foot cable that we provide. The thermostat ideally would go in an open space and not in a mechanical room behind a boiler or behind a refrigerator or directly in the sun, just because if the network goes down, it does revert back to its own temperature sensor in this thermostat. So if it's behind a boiler, it'll keep the cooling on and think it's 90 degrees all the time. Just keep that in mind. From there, the sheet metal guy or the mechanical is going to hang the boxes that come from Price with a controller on it, already factory mounted, ready to go and pre-programmed. So that's great. Couldn't get easier. And then what we do is we give you the cables to clickety click and daisy chain the backnet network together with these 35-foot cables that we provide from Price. You can hook up to about 30 devices, whether it's single ducts or Prodigies, off of one PRTU rooftop controller. As I mentioned, the cables are Cat 5 cables that we make here at Price, and they are tested and ready to go. Lastly, the contractor just needs to run a 10 conductor and wire in the 24-volt power and also the output side for the fan, stages heat and stages cool. So pretty straightforward. That's just a nice overview, quick overview of how this system would get wired and hopefully show you how quick it can go together. So built in the PRTU or within the thermostat and the logic are 4 strategies. So these come canned. They you know, you don't have to be a special programmer to set these up. But the most common is average polling. That's the default that comes in the controller. So if you got 10 zones and 7 are calling for cooling and 3 are calling for heating, well, the majority wins and cooling kicks in. Now you might ask, well, how does it know how many stages of cooling? Does it go into mechanical? Does it go into economizer? It's a great question. The PRTU controller calculates the PI within the rooms and calculates how far each room set point is away from the room temperature. Based on those demands, excuse me, it will calculate if it needs to turn on 1 stage of cooling or 2 stages of cooling. So the PRTU has this internal logic or this PI control that is always calculating as it scans the network over that BACnet network. Now, the Rooftop, whether it's a Train, Carrier, Lennox, Aeon, whatever it may be, is going to turn on or bring on economizer mode if the outdoor air will let it. So if the outdoor air is, good enough or nice enough where it can bring in some free cooling and allow the economizer to take over, it will do that. If the outdoor air is too great, well, then it'll kick into mechanical cooling. So keep that in mind. The Rooftop unit will handle its own economizer mode on its own. The next type of strategy that you may use would be a non-majority, where you might get a little bit tighter control. And this is where you'd favor heating in the winter or cooling in the summer. You'd set a percentage when you want those modes to kick in. TD Ameritrades use 35% cooling. We set all of them up like that based on the MKK engineers. So as soon as let's say we had 10 zones, as soon as it saw a 35% demand, it would kick on cooling, either one or two stages. It wouldn't really look at the rest of anyone. As soon as it saw 35%, it kicks in cooling. Now, the other type of strategy is the seasonal strategy that we have. And this works well too as an auto sort of changeover strategy also, where you set up the seasons of the month based on, seasons of the year, based on summer, winter, spring, and fall. So you're going to decide, like up here in Winnipeg, our winters, are a little bit longer. Out east there in Boston there where you guys are, your winters, you get harsh winters too, but probably not as long. So you could set up the seasons and and the months throughout the year for whatever the season is. So you have a nice auto changeover. So in the summer and the winter, it does the non-majority strategy. And then in the shoulder seasons, it does the average polling strategy. Now, in behind all of these strategies is this zone weighting. So every zone, any strategy could use this or utilize this zone weighting function, meaning, some zones can be weighted greater than others to influence or help control the building better. So if you have a perimeter zone with a southern exposure where the sun comes up and then it comes up in the day and then it gets hot and then it drops at night, you can influence or weight those zones greater than the interior zones so they can win a few more votes to help control their zones a little bit better. So just always remember, an exterior zone is a little more crucial than an interior zone. If you're trying to control, a copier room or a lunchroom that has interior walls, not really, it's important, but not as important as, say, those exterior ones that have like a skin load that need to be taken care of for sure. Excuse me. Okay. All right. So those are the strategies that are built in. Moving on to our VAV box controller. This is known as the PIC, or the Price Intelligent Controller. I actually started to write the manual when I started way back in 2008 when I started at Price for this guy, the service and install manual for the Price Intelligent Controller. This is our flagship DDC VAV box controller, and it can actually do more. It is a BTL certified controller, meaning it's BACnet Test Laboratory certified, meaning that we can play with other BACnet devices on a BACnet network that are also BTL certified. So this allows us to talk with and tie into all those other guys, whether it's Johnson, Honeywell, Siemens, Allerton, Automated Logic, Schneider. If you're BTL certified, you can talk on the same network and segment and work together. If anyone tells you that BACnet devices cannot talk together or to each other, they're lying and they don't know what they're talking about. BACnet devices that are BTL certified are like devices. Okay, so at Price, we say it's a universal controller because it can be mounted to any one of the terminal units that we have here at Price. But also, these controllers can be retrofitted for older boxes that have gone, maybe the box hasn't failed, but the controller probably has. So if you got some old train controllers out there, old analog controllers that have failed, yeah, you can retrofit a Price controller onto that damper shaft to control the box. Remember, you're just moving a damper shaft or a damper 90 degrees. It's not a big deal. And then you're firing some reheat, whether it's binary on off, 0 to 10 or pulse width or trice, whatever it is. The PIC controller has all those sequences to handle that. So you have a VAV box, either cooling only or cooling only with some form of reheat. Not a big deal. We can do it. Okay. So we say it's universal because it can go on any one of these types of boxes that we offer. So single duct, fan powered constant, fan powered variable, RDV, this is a round butterfly valve. So the old VVT style valves that you see out there. A linear gate bypass of a valve. This is box. This is an old dump box that we made in the 70s, but still big, still getting spec'd in Ontario, Canada. And then over in the bottom right here, guys, we got these dual ducts. So the PIC controller can be programmed and set up to do hot deck, cold deck type applications and control the dual ducts. So just remember, guys, when you're out there in the field, there's a lot of hospitals, a lot of universities that might need retrofits where these dual duct boxes are being controlled and operated by pneumatics. Pneumatics are dying. They're going by the wayside. So a DDC controller can be put onto these types of boxes. And what better solution than a price control? Okay, so here's a layout of the PIC controller essentially. The one thing or couple things I really want to point out here is the wide range of outputs we have for any form of reheat. So down here are all of our binary outputs up to 3-stage reheat. We're talking staged heaters in the ceiling, baseboard, radiant panel, whatever it might be. There's a lot of outputs, binary outputs for fan and for staged reheat, reheat that way. Up top, we have analog outputs that can handle, an ECM fan, but again, a heating valve, so hot water coil, so AO2, that's your 0 to 10 out to a hot water valve that would modulate either 0 to 10 or 2 to 10 or whatever it might be. As you notice, there's a bunch of jacks on the board. So here's the RJ45 jack for the thermostat. That's where you plug it in and just wire it in, so there's no real wiring. Down here is a smaller RJ12 jack for power. I'll get into that. We provide a cable that could provide 24 volts to the controller, so you just plug in the power. Pretty simple. And then on the back side here for the expansion cards, this is the backnet card. Here are the two RJ45 jacks that you would plug in the cables that we give you to daisy chain the controllers in a segment or in a daisy chain fashion, just clickety click from one to the other. So you don't need to actually wire the backnet network, which makes it quicker and easier to get in and off of a job site. Down below is this other expansion module, which is the airflow transducer, which comes, if it's selected through the selection software from Buckley in our selection software, it will come mounted to the box and tied to the crossflow sensor. This allows the controller to control to a CFM or an airflow, as opposed to just damper position, which would be more of a VVT type application. The other thing I want to mention is the supply air temperature sensor that gets mounted to the inlet of the Prodigy or the inlet of a single duct box. It acts as our heat cool changeover sensor. And what the controller does, the logic is as it receives a signal from the thermostat, it actually compares the thermostat temperature with the temperature in the duct where the supply air temperature sensor resides. So it compares the two and decides, do I need to move the damper more open or more closed based on what the demand is. So if someone's calling for cooling in the space, they set their set point to 68 and there's 55 in the duct. The controller recognizes that and says there's cold air in the duct, open the damper. If someone sets their set point to 68 and there's hot air in the duct, the controller recognizes that and closes off or pinches off the damper. That logic happens in heating mode as well. So if you're putting in your set point into heating. So that logic is built into the PIC and the Prodigy controllers or boards already out of, right from price. Okay, so that's the PIC controller. I mentioned reheat types. I just want to say, guys, the PIC controller can handle any form of reheat, whether it's binary on off, 24 volts, floating point, tri-state, 0 to 10, 2 to 10, reverse acting. This can all be set up through the thermostat, an LCD thermostat that will come with the controller in the VAV box or the Prodigy. So if you have two forms of heat that you want to achieve, like a primary and supplemental, meaning primary, you might control a hot water valve in the ceiling, and then secondary, you would turn on a baseboard. You probably want to turn that baseboard on later on in the demand. This PIC controller can get set up to do that with that type of sequencing. Okay, as I mentioned, a wide range of thermostats. The one that is the default is the LCD. And the reason this is the default is because it gives you the most information and it's the most interactive. So not only is it a thermostat, it's a thermostat, a balancing stat, and also a service tool all in one. So yes, the balancer can balance the box with this thermostat. Contractor can set up the MAC address or the BACnet addressing as needed. And then it's also a thermostat. And there's, service menus that you can get into to change parameters on site if needed, like min and max airflows, balancing, damper position, for example, output configuration. All of this can be changed right through the LCD thermostat. Now, starting sort of down at the bottom here, I'll start with the room sensor. It's a blank face sensor. It's tamper proof. It just senses temperature. No one knows what the room temp is or what the set point is. So no one can play with it or adjust it. One step up is the dial stat. So snowflake to a flame. You want it cold, snowflake. You want it hot, flame, piece of cake. No one knows what the room temp is or what the set point is. So that's good for when you have thermostat wars. You don't want people knowing what the actual temperature is in the room. The LCD, as I mentioned, is the best one to get to start off with. On top of that is the motion sensor stat, or the LCD stat with a motion sensor. It has a golf ball sensor in the corner that can sense occupancy and put the box into occupied mode. These are great for larger areas that are not occupied all the time, or maybe a, president's office, whatever it might be. He comes in, senses occupancy, puts the box into occupied mode, and you can even wire in lighting off of some spare outputs on the PIC controller. Now down at the bottom, we do have a wireless stat. This is just a thermostat that communicates with a receiver in the ceiling, and they work on a frequency. This thermostat in the space is a wireless dial stat that has 2 lithium-ion batteries, and it's just an RF frequency that they communicate on. It's not a wireless mesh. It's not a Zigbee type network. It's just a one-to-one relationship over the over radio frequency. Now, as I mentioned too, in the middle here, 35-foot cables that are provided by Price, plenum rated, ready to go with the RJ45 jacks. So you just plug it in from the controller to the back of a thermostat. And I'll show you that in the hands-on portion as we get to it. And lastly, we have the other type of LCD offering is a CO2 stat with RH, or relative humidity monitoring. So this stat comes with a CO2 sensor or module in the back of it, an NDIR sensor. So really what we're doing here is we're going to control the CO2 in a space and purge the space as needed as CO2 levels rise. So again, in a conference room or a meeting room where you meet every morning for a morning meeting, CO2 levels would increase. You're probably going to want to purge that room and bring in some fresh air. This CO2 stat could do that for you. All right. Lastly, on the PIC controller, available applications. So just to let you know, the PIC controller can get pre-programmed in the factory, mounted to a terminal box, ready to go based on how the Buckley guys select the sequences, whether it's a design build or an engineered schedule, whatever it might be. But anything from single duct to fan power to dual duct to, again, yeah, this PIC controller, I didn't mention it, but can control a fan coil or a chilled beam, 2-pipe and 4-pipe applications. So keep that in mind. And also for pressure control. So this controller has a wide range of applications that it can get programmed for. Okay, moving on to VAV diffusers. This is where we're getting to the top portion of our system layout there, where we have the offices and the Prodigy diffusers. So this is the Prodigy diffuser. It's been around at Price for about 20 years. One of the first developments of out of Price electronics, along with a couple of other things, but this was, or the Prodigy's been around for quite some time. Essentially, when you design in a system with Prodigies, the idea, and this is where they did it at the TD Ameritrades, the idea is that you would design the system static in for about 1/4 inch or maybe, 0.3 inches. So smaller, less static pressure leads you to smaller ductwork, reduced fan size. You can help save energy costs that way. It also gave MKK some lead points on these projects, and they put them towards their lead points as they went through designing these buildings and designing the TD Ameritrades. So this is our Prodigy master diffuser. Essentially, guys, this is the brains. This is the chassis. This is where the thermostat plugs in, the reheat connects, the 24-volt power plugs in, the drones will hook up, so drone diffusers, and even BACnet. So if you look at the top here, this stamp out on the chassis. Here are the two RJ45 jacks for backnet, and you just clickety-click these together in the ceiling and create your backnet network that way. So there's a lot of plug-and-play features on this Prodigy diffuser, which I think is great. Internally, this is what it looks like. It's a drive shaft that drives a damper up and down with this quiet AC, 24-volt AC motor. So the drive screw drives up and down and moves the damper from 0 to 100 or 10 to 90. Again, this device is a pressure dependent device. It's a VVT, so it doesn't measure airflow. It doesn't know airflow. It just drives from, based on damper position. So 0 to 100, 10 to 90, whatever you set your min and max parameters to be. But default from price, the defaults are 0 closed and 100 is full open. Okay, again, same wide range of thermostats we offer. So at price, it's universal. So I don't have to go through those again. CO2 offering as well. So we can do a purge type mode with a Prodigy in a room, or Prodigy, master in a drone. So here's the drone application. This is where you have a master and you could hook up to, say, 5 drones. So the drone board, guys, is this simple drone board that has 2 RJ12 jacks on it with a couple LEDs. This is just for the drone in and the drone out. The master sends the signal and the power to the drones, and we give you the cables. We give you the telephone cables to plug this stuff in. It couldn't get simpler. So you could do up to 5 drones. You might put this in a master and 4 drones in a conference room. You might put a master and 3 drones in a long hallway. And there's one thermostat kind of controlling all of those. All right, so getting into pressure control. As I mentioned, Prodigy system designed in around 1/4 inch of static, but how do you really control that pressure? Well, Price offers this PCV for constant volume type system. So we provide an RDV with a PIP controller mounted to the damper shaft programmed for pressure, and we provide this static pressure probe that needs to get mounted about 2/3 of the way down the duct. So once the contractor has done that, he's going to go get some pneumatic tubing and hook up the static pressure to the high side, the static pressure probe to the high side of the transducer. And then this controller will start to read the static pressure and control. When that's all done, you could hook up this thermostat on site with one of our cables and just make sure that the set point is actually set and that it's actually doing what it needs to. So as you drive in balancing mode, you would drive your dampers to a minimum position. The pressure would build up, and this valve should open up to relieve the pressure. So let's look at that here. This is a typical constant volume tight system, constant volume rooftop with a supply and a return duct and a bypass ducted in the middle or ducted in between them. This one's ducted back to the return, but I commonly see these just being ducted to the open or open return. The static pressure port is mounted about 2/3 of the way down the duct, and as these diffusers go to a minimum, the pressure will build up and the bypass would open up to relieve the pressure. It's a classic constant volume type system. The other type of system you would have would be a VAV or a VFD in the rooftop. So this would be where the VAV rooftop unit has its own VFD, its own static pressure port, and it controls the static pressure on its own. So all of that is tied in back to that really intelligent VFD. So the VFD is going to speed up or slow down the speed of the fan based on changes in static pressure. So it's going to increase or decrease the hertz to the VFD. Okay, so getting into power. All of our controls need some form of 24 volts. Doesn't matter if it's field supplied, factory supplied, whatever it is. It needs 24 volts to live. So at a price, we could provide a transformer. You could have a factory mounted transformer, pre-wired, ready to go right from the factory. You could have an electrician install, say, a 100 VA transformer and supply their own 24 volts. You could do that too. But if you want it done, efficiently and correctly, I recommend getting it done from Price. I've run into a lot of situations where electricians wire in their own transformer and then they don't observe the polarity. And anyways, this is all important for BACnet, but they don't observe that and nothing actually works until they change it. So anyway, so from Price, we could get a factory mounted transformer in the terminal box or on a Prodigy, pre-wired, ready to go. And then the electrician has to come in with high voltage. So keep that in mind. If you have 30 VAV boxes. An electrician would need to provide high voltage in pipe and conduit 30 times with 115 or 277, for example. To eliminate that and save time, we offer this price power module or this transformer box. It has a large 96 VA transformer that transforms down to 24 volts, and we give you the cables to hook this up. You don't need to be an electrician to hook up this low voltage stuff. You don't have to be a controls contractor to hook up this low voltage cabling. Essentially what you could do is get the electrician, he supplies high voltage once, and then he says, see you later. He flips the breaker, and then the contractor, whether he's sheet metal, mechanical, refrigeration guy, he can hook up the 24 volt with the cables that we provide. So essentially you can hook up 15 Prodigies or PIC controllers, as you see here, off of one power module. So there are rules and distances and voltage drops that need to be observed, but really you can handle about 15 devices off this one guy. This Prodigy, or sorry, this power module would get mounted centrally in the ceiling, and then you would disperse the 24 volts out to your devices. And then this is what it would look like for Prodigy. So this is, they use this in all the TD Ameritrades. There was no question. They use these in all of them. So it worked out well. So keep that in mind when you're thinking about labor cost, electrician time, and setting the job up with the amount of power. So that's our 24 volt solution. Okay, just quickly on networking, just mainly because this is for the contractors. Really what we're gonna do here, guys, we're hooking up a network, and I'll show you just quickly on the hands-on behind me in a few minutes. But really what you're doing is you're connecting a network from our main system controller here out to the devices, and we use BACnet. So that's what we use here at Price. The reason we use BACnet is because ASHRAE has a standard on BACnet. So we follow this ASHRAE standard. We're BTL certified, and we follow these standards. So BACnet is easy to use. It can go long distances, and it's very universal. You can use Cat5 cabling for BACnet. So that's why we use Cat5 cabling. Essentially, LAN is not really existent anymore, and BACnet has kind of won that war for sure. So just a couple rules when you're hooking up BACnet. You don't need to remember this. We have this in all of our manuals. We have a BACnet guideline, wiring guideline manual, and we're here for support. But really, when you're hooking up a BACnet network, you need to do three things. Each device needs its own address. They also have to be running at the same speed or the baud rate, and I'll just talk about that quickly. Our baud rate is 76.8. That's the speed at which the network communicates. Every other vendor out there, aside from Delta, so Johnson, Honeywell, Siemens, Allerton, Automated Logic, Schneider, KMC, whoever it is, they operate at 38.4. That's just, they were developed years ago. They operate at the speed of 38.4. If you want a price controller to communicate with a Siemens system, the baud rate has to be the same. It's as easy as changing it or flipping it over through our thermostat to 38.4. The Siemens integrator guy hits rediscover, and magically our stuff will appear on their front end, just to give you an idea how that works. Lastly, all the 24 volt needs to be earth grounded. The common needs to be earth grounded in order for the network to work. Polarities matter in BACnet, and if they are not followed, a BACnet network will never work. So those are just some rules that you have to follow. Again, as I mentioned, MSTP stands for Master Slave Token Passing. So essentially that BACnet network, all of our devices run on an MSTP segment, not a BACnet over IP. It is BACnet over MSTP, where it passes a token from client to server or server to client type relationship. And lastly, guys, we have this BACnet commissioning tool. So if you're on a site and the BACnet network's down and you can't get it in the ceiling and you don't have devices coming up and you're in a real tight spot, you can order this BCT from us. This has saved me on job sites, especially on finished sites, where you're sitting in a mechanical room, you're tied into the network, and you can see what devices are up and which ones are down. This thing is very useful if you run into some BACnet network issues where you can't solve them sort of on your own, out in the network with what you have. This can help solve and save your BACnet network problems for sure. Okay, Coming into the home stretch here, guys. This is, we're getting into our web server now. This is our Price web server graphical interface. So a mini front end that we offer at Price. I do want to mention this is not a full-blown front end system. It will not or does not have the capacity to monitor and handle, say, university campus or hospital, but we can tandem a few of them together to handle some points or more points. Out of the box, this will handle up to about 3,000 points or nodes. So you can ask me about that later. I won't get too much into that, but it's got quite the power for, for what it is. Again, this mini front end is not going to be, as I said, it's not going to be as much as, say, a full-blown Johnson Medicis or Siemens Apogee or whatever it might be front end system. This is meant for smaller to medium-sized buildings, and I'm going to say it's priced accordingly. So let's say you had a system like this, a nice rooftop with a PRTU and some zones and a bypass, and you got all your networking and everything's going great. You got a nice average polling strategy and everyone's comfortable. But building owner decides, hey, I want to be able to view these graphics, or I want to log in from home before I come in the morning. Or a contractor that has a service contract says, you know what, I want to put in a graphical interface in there so I can log in before I go to that site. I can log in remotely. Well, with the Price web server, you can do that. With the proper static IP that gets set up in the web server, you can log in remotely from home or wherever to view a site. So anyone on the LAN or remote could log in and view the graphics to their building. So it's a new HTML5 version. What that means is now you can view these graphics on your smart device or your smartphone. They're transformed and fitted so they fit on your phone. These are pre-built graphics within the web server, so you can build your rooftop. It has on animations for heating and cooling and fan. We have pre-built graphics for the VAV box, Prodigy, the bypass, whatever it might be. So all of this is pre-built drag and drop. It's really easy to set this stuff up. And we can help set it up, but a contractor could also set this up on site with our help. We do have the ability to create custom graphics as well, like custom floor plans. Those aren't pre-built in the web server, but we do have the ability here at Price in Winnipeg to build custom floor plans and graphics as needed. Also, within the web server, this is the main reason for it, you can build trends and alarms and set up email notifications based on these parameters. So you can trend points, set up limits. So if you too high of a limit, too low of a limit, temperature goes out of range, you can set up an alarm that would generate an email and email, say, the service guy. So this is what the web server does. Yes, this is not a full, but it is a front end system. So it has the same capabilities. So think about it, guys, when you have like a backnet network where you need a nice graphical interface, you could use this Price web server for an economic solution on getting that result. Okay, training and support. Just want to mention, as you take one of our thermostats off the wall, you will find our phone number here, our hotline that reaches us up here in Winnipeg. So we're here ready to help. I have an application team, specialist team behind me here that helps out. And primarily I do the sales side of things, but I've done application support for 10 years here out of Price. So I know this stuff through and through. So I'll help out as well. But yeah, we have a team here that will help you. That's what I'm getting at. So. And then commissioning, we can come out and commission, but due to these times, COVID times, it's tough to travel right now. And I know things are kind of easing up, but now they're kind of scaling back a bit, kind of clamping down a little bit more. So we can help out over the phone or do something virtual, but there's no reason why, if we have a contractor, and again, guys, we've gone all the way from Jacksonville to Cupertino, and we've helped every contractor and helped them set them up when we went to each job site. So if we get you on the phone, we can help out a contractor set this stuff up over the phone. It's really not that bad. It's pretty straightforward. Okay, so when to use Price controls? Retrofits, TIs, tenant fit ups, new installs. An old rooftop system that might have failed might need a new thermostat. Hey, think about the PRTU. You could put in a PRTU controller and create a polling network strategy in that building and give them some better, tighter comfort in that building. Think about that. Or existing VAV or VVT boxes that need to be retrofitted where the controller has failed. Retrofit a Price controller on there, no problem. So advantages: Factory mounted calibrated controls, no field programming really required, plug and play thermostat and backnet connections, all set up, ready for you to go so you can get in and off of the job site quickly and move on to your next job. Okay, guys, that's awesome. Thanks for sitting in. But what we're gonna do now, I'm just gonna take a minute, I'm gonna have a sip of water, catch my breath, and we're just gonna shift over to our control panel where I'll do about 5 minutes of hands-on. I'll just show you some basic plug and play functionality of the control panel with our controls, price controls, as the demonstration. Okay. All right, guys. So just want to mention, this is one of the control panels that we have here out of Price in Winnipeg. We have 4 of them where we do hands-on training with controls contractors, or any kind of contractor actually, where we bring in contractors. We do 2-day hands-on training with them to get them up to speed. So it's full 2 days. We kind of teach them everything we know about our controls. So on this panel, as you can see, and I know the camera's not great, but it's good for a demo. I know this is live. So, but on our panel here, we have a PRTU rooftop controller and its thermostat. We have a VAV box controller. This is the PIC SD. But we're really going to focus on the PRTU and the PIC controller because that's what we're talking about. The PIC controller is the easiest to plug and play. And then beside it is a Prodigy circuit board as well. This is what goes into the square plaque diffuser in the ceiling. And then over on the end of the table, we have a power module that distributes 24 volts. So all I'm going to show you here, guys, just quickly is how to hook up, say, 24 volts to this PIC controller. This is a C35 35-foot telephone cable that we make here at Price. It's an RJ12 or RJ12 jacks, and it's actually like a Cat3 cable. But we make this here at Price, plenum rated, ready to go. And all you would do on site is take one of these cables, it'll be white or gray, and you're going to plug it into the power module into one of the jacks. From there, you're going to find the jack on the controller that is meant for power, and it's right here. Actually, it's the only jack that you can fit the RJ12 connection into. And you're going to plug this into the power jack. I know it's tough to see, but the lights start to blink on the PIC controller. The thermostat comes to life. And now the PIC controller starts to calibrate for 2 minutes and zero itself so that it can start controlling based on the room demand. Now, the thermostat itself is connected with one of our 35-foot Cat5 cables. One thing to note, guys, you're going to get a whack of these cables on Price jobs. Half of them will be for the thermostat, and half of them will be for backnet. It's the same cable for the thermostat and backnet. It couldn't get simpler. It's a whole bunch of blue cabling, Cat5 cables that hook up the thermostat and backnet, and they come in 35-foot lengths. Now you might ask, well, what if I have to exceed 35 feet? We can provide couplers to extend those distances to get you to the place you need to be. Now, with the Cat5 cable in behind here, in behind the panel, I have a 35-foot cable. But what I'll do is show you, these thermostats have a nice set screw on the bottom. We provide it with a Allen key in every box, and you can spin them up to close them down. But what you do is you put the thermostat on the top and you snap it in at the bottom. So you remove them from the bottom and then come out to the top. But what I want to show you here, guys, is this simple Cat5 connection, RJ45 jack connection for wiring in a thermostat. You plug it into the back of the stat, run it down the wall to the J box or the electrical box, and then plug it in that way. And then up in the ceiling, you just plug it in this RJ45 jack here on the PIC controller, labeled T-stat. And you'll see that when you're in the ceiling. But anyways, it's in our manuals, but it's really straightforward to start. This way, wire this thermostat and get him up and running. Again, no real wiring required. Now, if we were going to hook up a backnet network, say from our PRTU out to our PIC controller that might be, say, 30 feet away in the ceiling, all we would do here is, let me just undo this guy. We're going to plug into the PRTU controller, and it actually has an RJ45 jack on it. So you just plug it in here, and then you would take this cable and toss it to your buddy, or just toss it across the ceiling to where the first VAV box is. And then all you're gonna do, once I get this guy out here, all you're gonna do is plug them in. It might be tough to see here, but it's in all our manuals, and it was in the presentation. You're just gonna plug it into the RJ45 jack on the backnet card. Immediately as you start doing that, plug him in, now you have some communication indication for receive and transmit, and this thing's going to start to try to talk to this PIC controller. You would then take the next 35-foot cable, plug them into the jack beside, and start to daisy chain up to 30 PIC controllers or Prodigy controllers on your backnet network. That, my friends, is a simple overview of how to plug and play our controls together, either with thermostat or backnet connectivity. And just wanted to show you how easy it is, and show you that these cables are made from Price. Everything's pretty much ready to go, which again can save you time and money on the install and on a job site. Okay, at this point, I'm going to sit back down, say thanks for tuning in. That is the overview of Price controls from Price for our controls blitz with Buckley. And thanks for tuning in. And if you have any questions, don't hesitate to contact me or your Buckley rep. We're here to help. We're here to help push and really get a push on these controls, get these out in the market, and see if we can really go after these small to medium-sized type buildings. Thanks for tuning in.